So here we are going to discuss about the Bernoulli's equation. Initially, we will discuss about the general characteristics and mathematical equation of Bernoulli's equation, and then we will discuss about the physical representation of each head involved in Bernoulli's equation. It is always to remember that it is the law of energy conservation and it is the form of steady flow energy equation for incompressible fluid. The mathematical expression for Bernoulli's equation is P by rho g plus V square upon 2g plus Z is equals to constant, where P by rho g is pressure energy per unit weight or called as pressure head, V square by 2g is kinetic energy per unit weight or it is called as velocity head, and Z is equals to potential energy per unit weight, which is also called as datum head. And the sum of all three heads or energy is total head or total energy per unit weight. To understand the physical representation of all the heads involved in Bernoulli's equation, consider a flow through a pipe. Let the pipe is placed at a certain distance from the reference. Suppose a point P is inside where we have to calculate all the heads. A piezometer is there to measure the static pressure of the P. A pitot tube is there to measure the velocity head of the P. The reading of piezometer will represent the pressure head. The reading of pitot tube, that is rise of increase of fluid above the static pressure head, represents the velocity head, and the total distance from the reference represents the total head or total energy, which is the sum in the Bernoulli's equation. The another mathematical representation of Bernoulli's equation is P by rho plus V square by 2 plus Gz is equals to constant. Here all energy are per unit mass. The assumptions for Bernoulli's equation are: flow is steady, flow is non-viscous, fluid is incompressible. On integration of Euler's equation for incompressible fluid along a streamline, we get the Bernoulli's equation. So, if you found this information useful, please do subscribe and like the channel.